Imagine you're downloading data from a site and suddenly need to halt the process. The Abort controller in JavaScript to the rescue. First, you whip up an instance of Abort controller. It comes with a nifty thing called a signal, which you extract, like pulling a rabbit out of a hat. Then, you signal the fetch request, giving it the green light to start. But keep in mind, if you need an emergency brake, this signal can stop the fetch in its tracks, ensuring you're always in control. Cool, right? Imagine you're downloading a large video, but suddenly need to stop it. In JavaScript, you can create an Abort controller, which gives you a signal object. When you start fetching the video, you pass this signal to the fetch call, linking the two. If you need to cancel the download, just click an Abort button. This button's click handler calls the Abort method on your controller, stopping the fetch in its tracks. You'll see a console message confirming the cancellation if it gets halted mid-download. Imagine you're downloading multiple videos at the same time but suddenly need to stop all downloads immediately. That's where an Abort controller comes in handy. By setting up one controller with a shared signal, you can link it to several fetch requests. Then, with just one call to controller Abort, you instantly cancel all the ongoing downloads. It's like having a universal stop button for all your downloads, ensuring they halt at once without having to stop each one individually. Imagine we're about to kick off some work but need to make sure we're clear to start. Just like checking the weather before a picnic, here we check if someone's already pulled the plug on our task using signal aborted. If that's true, we immediately stop and say, "Whoa, we're not going anywhere. This task was cancelled." But if all's clear, we dive into our work, setting a timer to complete it. Unless we get an Abort signal partway through, then it's pull the brakes and shut it down time. So check this out, you've got this code set up to handle a fetch operation for downloading a video. But, here's the cool part. If you need to stop the download for some reason, you can abort it using an Abort controller. When that happens, you've got an event listener on the signal that logs a message and lets you clean things up properly. It's super handy for managing your downloads, especially if something goes wrong or you just need to cancel for whatever reason. Hey, check this out. We're setting up a fetch request to grab a video file. But see, we don't want it to hang forever, so we're using Abort signal timeout to give it just 3 seconds. If it doesn't finish in time, boom, it gets cut off, and we handle it gracefully by logging fetch request timed out. If it works, we log the success. Pretty neat way to keep our fetch calls in check, right? Let's see how it goes. Imagine you're downloading a video but you don't want it to take forever, so you give it 5 seconds max. To handle this, you combine two signals, one from an Abort controller, which lets you stop the download manually, and another that times out after 5 seconds. If you decide to cancel or it takes too long, the code catches it and tells you whether the download was aborted by you or because it timed out. Simple and super useful, right? Imagine you're building a super smart function that can stop fetching data on demand. You hand it a secret signal, and if you suddenly decide you don't need the data, you just wave that signal, and boom, the function halts right there. So, you try it out. You start fetching some data, but a second later, you change your mind, wave the Abort signal, and the function immediately stops the data quest and tells you, fetch aborted. Pretty cool way to save time and resources, isn't it? Imagine you're streaming your favorite show and suddenly you need to rush out. You hit stop, but what about the data still downloading? That's where proper Abort handling comes in. We stop the download using an Abort controller, like slamming on the brakes. Now, if there's an error, we check if it's because we aborted on purpose or something else went wrong. Whatever the case, we clean up by setting the controller to null, just like you turn off the lights before leaving the house. It's tidy and prevents unnecessary data charges or errors later on. When releasing the reins on a fetch call with a timeout, it's like setting a watchful guardian over the task. Imagine giving the fetch mission 2 potential endgames, success within the slotted time or a halt signal if it dawdles. If the operation turns sluggish and misses the mark, we gracefully shut it down. Just remember, when the job's done, clean up after yourself. Unhook any events linked to the task to prevent those sneaky memory leaks. Encase the abort strategy in its own cozy function for a tidy and reusable approach.